Hey, what's up? Today we're gonna solve this problem, 1329, which is sort the matrix diagonally. And first, understanding the question is very intuitive. It just asks you to sort it diagonally. So how do we approach this problem would be, okay, think about it. So at first, the first thing we notice is a sort of pattern that, okay, let me just think about it. Okay, my first idea is the following. So we start with this corner, and then in this corner we can just find one element, and then we can travel down, which is basically the I minus one or j minus one. Then we can find this one, and yeah, we can do something like I plus j, and the sum is equal to a certain value, and then we increase or decrease the value to make sure that it travels diagonally. And when it travels diagonally, what we can do is that we do two for loop. One for loop will put the element into an vector, and then we use the built-in sorting function to do the job, and then we put it back. And I think this works, so let's just code it up. So let's think about it. What's our condition? Yes, so we will be starting at this corner, and this corner which have just use this example one as a reference. So this element position will be 0, 3, and we can observe the sum would be 3, and then the second one it will be 2, 0, and 1, 1, 3. Okay. So maybe it's not that what I thought. Can we observe a pattern? Yes, the difference is 2. So yeah, if the difference is 2, then so here the difference is 3, and then here the difference is 2, and below difference will be 1. I guess we can observe that from here it will be 1, 0, and 2, 3, and 3, 4, and then we can observe a simple pattern here, which is to separate diagonally, then we can observe that their difference would be always same. I mean, yeah, it just decrease for each diagonal, which here is 3, here is 2, and here is 1, and here will be 0, and here will be -1, and here will be -2. So we can store a difference variable here, and what's their first difference? So their first difference should be just the length. So int diff equal to mat.size, and this shall be our beginning. This shall be our starting point, and here we will do a while loop. And also, what's the difference? Here the difference should be 0, negative, so it will be 0, 2, and if you do that, then yeah, and then let's call it stdiff, and then int nddiff equal to @0.size. So one represents the starting difference, one representing the ending difference, and so we can do that while stdiff smaller than adddiff. Then we do something here. Do some sorting diagonal. And then travel to next diagonal. stdiff plus. And here we can let's just separate the logic here. I'm gonna just create a helper function, which will be my helper. And this helper function shall take two arguments. One is this vector int, and one shall be our int diff, and then here we can so here it's not running like intuitive for me to how to starting the diff. Like, can we use the diff to calculate our starting position? So yeah, so actually can we I think about it. So there's one thing though, wait a second, I think I got it. So I got idea here that although here the diagonal only have one element, but technically we can try to expand it. We can visualize it as this way. But when it outside the boundary, we simply stop and to mimic the such behavior, and so that we're having it. And yeah, we should try it now. So here is diff, and here is the mat, and our starting position would be if here starting position if diff is greater or equal to 0, then we need here int I and j declared. Then I will be diff and j will be 0. Else, our second pattern will be no, I don't need that. So I can just simply make I equal to diff and j equal to 0. And here we can do some while loop. And this while loop is while j smaller equal to just smaller than mat 0 dot size, which is a column, and it will travel like going down stair, and the stair is just column size. So as here we simply care about the vertical. If you know what I mean, it's like only care about vertical dimension here, and then we also filter out those elements that do not exist. And to be able to sort here, we need to create our vector int. Also here, like anyway, 100 element, I think it's fine for me. Just call it vi. And then what we're gonna do is that if suppose that I is smaller than 0, or alternatively, could I be greater than 0? Yeah, could be. So I greater or equal to mat dot size. Suppose that, oh, there's one more thing. Yeah, I didn't realize. So actually, at here I should be represent horizontal, which it should be mat 0 dot size, and here j should be size. And it is correct though. I think diff is correct. Although at here I need to change it as well. So just make sure it work. Add diff. Yeah, I think it worked. Okay, and here suppose that this happened, this condition happened, means that this element is visualized by us. So it could be here or it could be here. Then it shouldn't be exist. So at here we simply ignore by continue our. Oh, we cannot continue. Let's make it for loop so that we can make it continue. For j already initialized, j is more than that. J++ increment, and here we can make continue to skip those elements cannot be put yet, and the next one we just we do a pushback. And here it should be ij. It should be ji or ij. I'm a bit double with that. I think it's ji. Oh, right. Else we put it to ji, and then we. Okay, and then let's also make a counter equal to 0, and the element size should be the same. And here we just sort the array, I mean vector. So yeah, we're sorting the vector, and then we do the same for loop, and then at here we also continue. Else, what we do is that mat ij equal to vi counter, and then we also increment the counter, and Like this, we're sorting it. And here we use this helper, and it takes 2 arguments. One is our matrix, and one is our different is stdiff. At the end, we return matrix and see if this solution work. Yep. Oh, yeah, copy paste it. Okay, it's not quite work. Let's see what's difference. So, okay, then sort it. Oh, that's interesting. Oh, right. So wait, no, that meant it's not a problem. So here. Oh, right. We didn't do increment and decrement. Also, here only did for j, but we didn't for I, and so it should be j plus plus and minus. I'm not sure about that. Can I do this? Okay, I can. So it should be j plus plus and I minus minus. Oh, still no change. Weird. Does that increment? Funny story, didn't get into this loop. J smaller than. Okay, I think this is allowed. Not sure the problem. Yeah, it should be plus plus. I see. So at here it should be j plus plus and I plus plus. Should be I plus plus. Okay, it should be -1. That'll work. This is a bit weird. So this means that this is not getting executed, but like here, j is smaller than mat.size, and this should be obviously be true because j initialized at 0. Oh, I see why. I see why. So, oh, okay. I know the problem. Yes. So here I didn't do it well. It should be. I'm sorry. They should be positive. They should be negative, and then it should be greater, equal, and here should be decrement. I think that's my logic. If I want to start from here, okay, it worked. And yeah, try more example. Okay, doesn't work. Oh wait, yeah, realized my mistake. It worked. Submit. Cool. And look, very fast, efficient solution. Thank you for watching.